Okay, so we're gonna follow a couple steps, okay? Before I can switch the y to x, what must I do before that? What do I have to do to start to find the inverse of the equation? Okay, so the first step is we're gonna switch that f and x to a y. Okay, we're gonna switch the f and x to a y. So y equals x squared minus 4. So that's step one. So we're gonna change f and x to a y. I know it's missing from the points above. Okay, now what can we do? I already gave it away. Next one, Samantha. No, sorry, Valentina.
Yeah, you switch your x and your y.
Change our x and y. Okay, so we're gonna change the position of just a letter. Just a letter, now we're not changing the exponents, we're just changing the letter. So x equals y squared minus 4. So change the x and y. And now, what do we do now? Oh my God, I wanna say Amanda, right?
You solve for y.
Solve for y. Okay, now we're gonna isolate for y or solve for it. So we wanna get y by itself. What's the first thing we have to move or cancel out? Artemis. Move the 4 over. Okay, so it's up to you guys which way you've learned or what you're comfortable with. So one is you can bring the -4 over the equal sign and make it a +4. Technically, that's not proper math. Okay, but if you do it, that's fine. I'm okay with it. What I do is just whatever you want to cancel out. So you add 4, and whatever you do to one side, you have to do to the other side. You don't have to do my method. So this -4 plus 4 canceled out, so that we get on this side, we get x plus 4 equals y squared. Okay, but if you move everything left, right, or over the equal sign, I'm okay with that. This is all the way been taught. Okay, and now is y by itself? No, we gotta get rid of the square. So we do that by doing what operation? What operation to cancel it out, Artemis? Square root. Okay, so we square root. And now we have y equals the square root of x plus 4. I forgot to put my steps here. Solve for y. I just changed the order, so it was the square root x plus 4 equals y, or y equals the square root of x plus 4. Okay, and one last step, Amanda.
You have to get y -1.
Good, so we're gonna change the y into f inverse. So last step is to change y to f inverse. Okay, now let's graph it. Okay, the easiest thing to do for graphing is just plug values in, and then plug in values for x, so like -2, -1, 0, 1, 2, and then plot them, okay? But let's try to think about how the graph is without doing the points. So what function do we have here? What function do we have? What function? If it has a square, Amanda, we have a quadratic. Okay, so this is gonna make a parabola. So in the parent function, y equals x squared, quadratic, it starts at 0 and 0, right? So it'll go here, and we have the two arms going upwards. Okay, but we have a -4 here. What does this -4 do to the graph? Going by 1.4, the lesson yesterday, what does the -4 do? Nowhere?
Move it down 4.
Move it down 4 spots. Okay, so instead of 0, 0, it is now at 0 and -4. Anyone learn the shortcut to graphing quadratics? The shortcut? So from here, I could just do a shortcut and get all the points. Know it? If there isn't any stretch or compress, there's a shortcut. Amanda, you know it?
Isn't it like if you get the points from one side, then it's just symmetrical?
Yeah, that's part of it, yes. But well, let's get points to one side without plugging numbers in. You know the shortcut? You just do this, 1 to the right, 1 up, that's the point. 1 over and 3 up is the next point. 1 over and 7 up. If that's how it works. Okay, so 1 to the right, 1 up, 1 to the right, 3 up, 1 to the right, 7 up. So you go up by 2s.
And that's with no stretch or compression.
That's no stretch and compress. If there was a stretch and compress it, you would divide or multiply by that value. Just want to double check just to make sure. If I plug in 2 there, yeah, 2 and 0. And that's 1 arm. And now we just reflect it to get the other arm, right? So 1 to left, 1 up, 1 to left, 3 up, 1 to left, 7 up. Did anyone know that one? Or just didn't want to say it? You knew that one?
I know I learned it, I just remember.
Just forgot it?
Yeah.
Okay, so now there's 2 ways you could graph the inverse. 2 ways. One's an easy way and one's a more difficult way. So one way is to look at the actual equation and say, well, it's a square root. This 4 is 4 units to the left, and then work from there, okay? What's the easier way to get to the inverse? The easier way, Artemis?
You just get to those points and just switch them.
Exactly. So just take the points and reverse the positions. So if this is 0, -4, then the reverse would be -4 and 0. So we're just going to swap the points. Then we have 1, -3 becomes -3, 1. 2 and 0 becomes 0, 2. And then 3 and 7 becomes 7 and 3. That gives you 1 arm. And then we're reflected to get the other arm. -1, -3 becomes -3, -1. This way. Kind of looks like weird because it's reflecting diagonally. So it kind of looks awkward. Okay, so we found the inverse, we graphed both of them. CS is the inverse f and x of function. Is a function, Artemis?
No?
No. Why?
It doesn't have the vertical line.
Exactly, it doesn't pass the vertical line test. Vertical line test, VLT, vertical line test. So now where I was telling you guys last week that the square root function, I said, you learned last year that the square root function was just one arm, but then sometimes we look at both arms. So if you learn the square root function, it should have been just this arm, right? But in some cases, we look at both arms, okay? Because, what was the reason again? Why is there two arms for the square root function that we discussed last week? What was the reason? There's supposed to be two arms, not one. Who told me? Antina?
So when you have a square root, it can be plus or minus.
Good, because when you have a square root, it's plus or minus. Okay, so you get the plus values, the positive values and the negative values. Okay, so let's do the domain first. So for the parent function, a quadratic or domain is what? Domain. Artemis? XER, excellent. Always, for quadratic, it's always XER. And if for some reason it's a real life question, then it will have restrictions. But XER for just a regular quadratic. Okay, our range. Range, go again.
YER slash, y is greater than or equal to -4.
Excellent. Okay, so YER such that y is greater than or equal to -4. Okay, so it's all our y values touching -4 and upwards. Okay, now it wants the domain and range of the inverse. Inverse. The easy way, Ariana?
It's gonna be XER and then x is equal to and greater than -4.
Good, so it becomes reverse, right? So the range becomes the domain, and the domain becomes the range. So you just swap them. So the range is YER here. And remember, y is in the back, it might say f at x. And with the inverse, you might see this. F inverse negative 1x ER. But I'm okay with the y, okay? And then your range becomes the domain. So XER such that x is greater than or equal to -4. Questions? Any questions with that? Did anyone not do inverse last year? Anyone not do inverse? I should have done, okay. Just want to make sure. All right, last example. So number 3, we're just determining the inverse. Okay, this goes something a little bit more difficult. So that's volume, or V equals 4/3 pi r cubed. Pi r cubed. I'll write that out better. I'm showing you a real life question because it kind of breaks some of the rules. Since there's no longer a y and x, we don't need to do any changing. Okay, we don't have to change the y and x here. So what we do, okay, is there's still an x value and a y value. So that's the volume and the radius. Okay, so the volume is considered the y and the radius is the x. Because as you change the radius, your volume will change. Okay, but we don't have to swap them. Okay? All you have to do is isolate now for r. So we just get r by itself. So if you have a real life question or a real life equation, because this is a volume equation, you don't have to change the letters around. So you skip the first two steps. So all you have to do now is just isolate for r. Right? So there's no inverse of x. There's none of this when we're doing real life questions. Okay, so I'm going to isolate for r. What would be my first step to solve for r or isolate for r? Okay, get rid of or cancel out first, or move first. Okay, so what I usually do when I see a question like this and it's a fraction, I try to get rid of the denominator. Okay, so I try to get rid of the fraction, because it's always easier to work without fractions. Okay, at least for me. So I want to get rid of the denominator so I don't have a fraction. So right now we're dividing by 3. So if I want to cancel out that 3, I need to do what? Multiply by 3. So we're going to multiply by 3. This is all being multiplied, so multiply by 3, multiply by 3, and this cancels out. So we have 3v, so v times 3 is 3v, is 4 pi r cubed. Doesn't matter where you put the times 3. If you want to put the times 3 here, and cross it off this way, it's up to you. Or some of you guys might do the cross multiplies, so 3 times v, cross multiply here, and get your 3v. Next step. Next step. This is great having you guys like this. What do we cancel out next? Amanda? Okay, so divide by 4. We could do a little bit better than that. We could do a little bit better. Let's go, Caitlin. 4 pi. Because pi is a number, right? So these are two numbers. So let's get rid of both of them. Because pi is 3.14 and so on. So we're going to cancel them out both together. And now our very last step, we want to get rid of the cube. The opposite operation of cubing is your cube root. So we cube root to cancel out. So we have r equals the cube root of 3v divided by 4 pi. Okay, that's the full lesson. I'll give you guys, oh, we got good timing. You guys have, let's see how long my next lesson is. You guys got almost a full hour to work on these questions here.